So for about 100 years, many scientists believed that atoms were small, round, hard, indestructible objects until J.J. Thomson came along. Now, I'm first going to show you the parts of his model of the atom, and then I will explain how he came up with it. So this is J.J. Thomson's model of the atom. He believed that atoms were actually made up of smaller particles. These small particles had a negative charge, and he called those small particles corpuscles. We call those small particles electrons today. But he called them corpuscles, and he believed that these small particles located within the atom had a negative charge, and they were embedded in this positively charged goop. He called this the plum pudding model of the atom, which theorizes that the atom consists of a big blob of positive charge into which negatively charged electrons are embedded. Now, plum pudding is an English dessert. We can liken it to, say, a chocolate chip cookie. The chocolate chips being the electrons and the cookie part being that positively charged goop. Okay, so this is J.J. Thomson's plum pudding model of the atom. How did he come up with this? He used something called a cathode ray tube. Basically, a cathode ray tube consists of a big empty glass tube with an electrode on each end, and each electrode is hooked up to one side of a battery. The cathode is the negative electrode, and the anode is the positive electrode. When you fire this thing up, you can see a beam of particles moving from the cathode to the anode. This beam is called a cathode ray. Now, you can't actually see the beam of particles, but what he did is he surrounded it by this phosphor coating, so every time a particle hit this phosphor coating, it would lighten up, and he could see that light hitting it, and he would know that those particles were there. And he knew that these particles had to be smaller than an atom. They were not atomic particles. Something about them was smaller. Before his experiments, it was thought that atoms were the smallest particles of matter, and he proved otherwise. Now, he also discovered that these little particles were negatively charged. He did this by putting charged plates near the tube, a negative one on the top and a positive one on the bottom. And when he fired these negative and positively charged plates up, allowing electricity to go through them and to become positively and negatively charged, this beam of electrons that was normally straight bent toward the positively charged plate. What this tells us is that these particles had a negative charge. And the reason we know this is because negative attracts positive and negative repels negative. So if you held that positively charged plate close to that beam, it would bend very slightly toward the positively charged plate. So he discovered two very important things with these experiments. First, he discovered that there are particles smaller than atoms. It was thought before, based on Dalton's atomic theory, that atoms were the smallest particles known and that they were indestructible. Well, it turns out that these particles are smaller than an atom. He also discovered, using those charged plates, that this beam has particles in it that have a negative charge because the beam moved just slightly toward the positively charged plate. So if this beam has a negative charge, it would be attracted to the positively charged plate because positives and negatives attract. Also, it would move away from the negatively charged plate because negatives and negatives repel. So it would move away from that negatively charged plate. So these are two really important things that hadn't been experimentally discovered or proven at this point. So that's why he is credited for this model of the atom. Now remember, his model of the atom is the plum pudding model. It tells us or shows that atoms actually have smaller little pieces called electrons, negatively charged pieces. And he believed that these negatively charged pieces were located in this goo or the sea of positive charge because he knew that not all things were charged. Most things were electrically neutral. So there had to be some positive in an atom to balance out these negative charged electrons.